Guys, in this video we are going to be talking about the mathematical representation of progressive wave motion. This is Tutor Malvis and I'm glad to come your way again. Alright, when we talk about progressive wave, we are talking about any wave, whether transverse or longitudinal, that spreads out from a vibrating source and moves through a medium, transferring energy as it travels. And of course, this graph you are seeing here is the graphical representation of a traveling wave, all right? So here we have the amplitude, the maximum displacement of the wave, and here we have lambda, that's the wavelength, distance between successive crest or trough, all right? And my major focus in this video is the mathematical representation of progressive wave and how to deploy it in different circumstances. All right, so for a progressive wave motion, y equals a sine kx, where our y is the vertical displacement of the oscillating wave particle, vertical displacement of the wave particle. All right, our A is the amplitude, our K is the wave number, K is the wave number, all right, and X is the horizontal coordinate from the origin of the oscillating wave particle or the wave motion, the horizontal coordinate. All right, now for wave number, which is K, you need to recall that K equals 2 pi over lambda. And of course, lambda is wavelength. Lambda is wavelength. And so if I decide to substitute 2 pi over lambda for K, I'm going to have y equals a sine 2 pi x over lambda. And this is the equation of a progressive wave. Now, let's proceed further from here. One thing you must understand is that a wave can travel in either the positive x direction or negative x direction. And the implication of this is that the equation for each circumstance, all right, vary. So, a wave that is traveling with amplitude A and constant angular velocity can be written as y equals a sine omega t minus phi. So you can actually take this as equation 1, all right? Then you can take this as equation 2. But before then, don't forget that I said a wave can travel either in positive x direction or y direction, or positive x direction or negative x direction. How will you know when the wave is moving in a positive or negative x direction? Sometimes they will state it in the question, all right? And sometimes they won't. So if a wave is moving from left to right, that is positive x direction. But if it is moving from right to left, that is negative x direction. So what's the difference? So this, we have y equals a sine omega t minus phi, all right? This is negative direction. This is negative x direction. So for the positive, we have y equals a sine phi minus omega t. So this is for the positive. So we can call this equation 2. So the only difference is you interchange the position of. So what is phi? Phi is also known as phase difference or phase constant. Are we together? And what is our phase difference? Phase difference is 2 pi x over lambda. So it's important we know this. Let me call this equation star 2. And let me call this one star 1, our wave number. Let me call this star 1, because I'm going to be needing it later. All right. So it's important to know that y equals a sine. So instead of writing phi here, I can decide to write 2 pi x over lambda, 2 pi x over lambda minus omega t. Omega is the angular velocity, all right? Or you can have a sine omega t minus 2 pi x over lambda. Don't forget, when you are dealing with the positive or the negative, you just swap the positions of the terms. So now that you get the logic behind that, I will just continue by using one of the formulas to solve instead of writing the two. So let's just maintain one. So this is, you can call this equation 3. All right. Another very important substitution that you can do is omega itself is 2 pi f. You can call this equation star 3. If omega is 2 pi f, I can have y equals a sine 2 pi ft, all right, minus 2 pi x over lambda. So here, instead of writing omega t, I just put 2 pi f, then this t making 2 pi ft minus 2 pi x over lambda. So this produces equation 4. Are you getting it now? And then you need to recall that f equals to 1 over t. All right? That's frequency. You can call this equation star 4. Don't also forget that v equals to f lambda. So f can also be v over lambda. You can call this equation star 5. So let me substitute 1 over t for f in equation 4. So we have y equals a sine 2 pi. So instead of writing f, I write 1 over t. So that will be 2 pi t over t minus 2 pi x over lambda. All right. So you can call this equation 5. So from here, another thing you can do is you can decide to factor out 2 pi. Factor out 2 pi. So you can have y equals a sine 2 pi into t over t minus x over lambda. You can have this to be equation 6. And of course, you know that f is your frequency, the small t is specific moment in time, and the capital T is the period. That is the time taken to complete one oscillation. That's period of oscillation. That's the capital T. Okay. Another thing you can do is factor out lambda. Factor out lambda. If you factor out lambda, so you are going to have y equals a sine 2 pi over lambda into lambda t over t minus x. Then you can call this equation 7. Then from equation star 5, I said v equals to f lambda, all right? And If v equals to f lambda and f equals to 1 over t, then we can say v equals to lambda over t. So, alright, so if v equals to lambda over t, anywhere you see lambda over t, you can put v in equation 7. So that is y equals a sine 2 pi over lambda into, so this is lambda over t, so that will be vt minus x, alright, and we can call that equation 8. Alright. So another thing that we can do, don't forget, what's v? V is wave speed or velocity. From equation star 1, star 2, star 3, I can have a sine omega t minus kx. Alright, and I can call this equation 9. Then looking at equation 5, I can decide to factorize this equation, and if I do, I'm going to have y equals a sine 2 pi into ft minus x over lambda. Then I can call this equation 10. So these are the possible combinations of equations that you can have to work with in progressive wave motion. Alright, and it's important to know that you can manipulate any of these as you want. So if you are given a question, and in the question the equation given to you, for instance, is not 2 pi x over lambda like this, 2 pi x over lambda minus omega t. If this is what they give, so you apply this. But in the case of this, you have 2 pi ft minus 2 pi x over lambda. The question might require you to use 2 pi x over lambda minus 2 pi ft. Just interchange the positions. So that was why I told you that we can have the x, positive x direction or the negative x direction. Look at this also. You can have 2 pi t over t minus 2 pi x over lambda, or 2 pi x over lambda minus 2 pi t over t. And then for equation 6, instead of t over t minus x over lambda, you can have x over lambda minus t over t. Alright? And for this, instead of lambda t over t minus x, you can have x minus lambda t over t. And for equation 8, this one is very common in most questions that they ask. So it's important you know this very formula. A sine 2 pi over lambda into vt minus x. So the question might require you to use x minus vt instead of vt minus x. It depends on the direction of the wave. And this is omega t minus kx. You might be required to use kx minus omega t. And this is ft minus x over lambda. You might be required to use x over lambda minus ft. So let's see how to use some of these formulas. Now, not everything here, is important in terms of solving questions, all right? What I simply did was to factorize, substitute, and all of that so that we can get different kinds of equation that you can possibly use or even come across as you solve questions under progressive wave. So let's take some examples and see how to use these formula. Alright, we have these examples. Question 1. A progressive wave has a wavelength of 50 centimeter. Calculate the phase difference between 2 points at a distance of 20 centimeter apart. So if they are 20 centimeter apart, the implication is that our x is 20 centimeter apart. That is, I'll be 20 centimeter. That's the distance from origin. Okay. Then for wavelength, that's lambda equals to 50 centimeter. And they ask us to find the phase difference or the phase angle. that is phi, and it is 2 pi x over lambda. Now what you are going to notice here is that our x is given in centimeter and our lambda is given in centimeter. That is why I'm not going to convert it to meter. Under normal circumstance, you're supposed to use meter, not centimeter. But because both of them are given in centimeter, they will eventually cancel out. But if one of them is given in centimeter and the other is in meter, you must convert them to meter. So here we have 2 times pi times x, 20, over lambda is 50. So that is 40 over 50 lambda. That is 4 over 5 pi. And be 40 over 50 pi, that is 4 over 5 pi, or 0.8 pi. Okay. Now, we often use this method if you are asked to, express your answer in terms of radian, So pi here is, 180 in radian. Do you understand? But under normal circumstance, you know what pi is in your general mathematics. That's 22 over 7, or 3.142. Okay. Look at this. Question 2. The distance between 2 points P and Q along a wave is 0.05 meter. If the wavelength of the wave is 0.10 meter, determine the phase angle. Okay, they said the distance between 2 points. So that would be x is 0.05 meter. And the wavelength is 0.10 meter. We are told to find the phase angle. That is phi equals 2 pi x over lambda. That will be 2 multiplied by pi multiplied by 0.05 all over 0.10. So 2 times 0.05, 0.1, 0.1 divided by 0.1, we have what? We have pi. Alright, let's look at question 3. A traveling wave moving from left to right has an amplitude of 0.15 meter. When you are told that a wave is moving from left to right, that is positive x direction. Okay, a frequency of 550 Hz and a wavelength of 0.01 meter. The equation describing the wave is... Now, for us to know the equation describing the wave, let's first write out our parameters. All right. So we're given amplitude, that's A. We're given A to be 0.15 meter. We're given frequency to be 550 Hz, and we're given wavelength lambda to be 0.01 meters. Now, looking through this option, you are going to see that the equation we have here look like one of the equations we have in our arsenals. So you just go and bring out the one that look like this, and that is also on positive x direction. And that is y equals a sine 2 pi over lambda into x minus vt. So if it is traveling on negative x direction, that will be vt minus x. But since we are told it is positive x direction, that is from left to right, that is x minus vt. So this is what we are going to solve before we can pick any of these options. So now that we have y equals a sine 2 pi over lambda into x minus vt, let's begin to substitute. We already have a to be 0.15. We have lambda, but we don't have v. We don't have v. So x will remain there as constant, y will also remain as constant. We don't have v, so we need to find v. V, which is wave speed or velocity, is f lambda, and that is 550 multiplied by 0.01. 550 times 0.01 is 5.5. So this is 5.5 meter per second. So anywhere we see v, we can now put 5.5 5. So let's go back. We have y equals a sine. So we now have, instead of a, we write 0.15 sine 2 pi. That is 2 pi over lambda. That's 0.01 into bracket x minus vt. What's vt? V is now 5.5t. All right. So we have y equals 0.15 sine 2 divided by 0.01 will give us 200. That's 200 pi into x minus 5.5t. So this is the equation of the wave that is required. Let's go through our options and see. So looking at these options, we can see that option A is the correct answer.
Question 4. The equation of a transverse wave traveling a string is given by y equals 0.3 sine open bracket 0.5x minus 50t, where x and y are in centimeters and t is in seconds. Find the maximum displacement of the particle from the equilibrium position. All right, what is required of us in this question is the amplitude. We are supposed to find the amplitude. That is the maximum displacement of a particle. So what we need to do is look at what is given to us. 0.3 sine 0.5x minus 50t. Then you look at your arsenal and think, which formula do I have in my arsenal that look like this? So without thinking too much, you know that there was a formula that is this: y equals a sine. Now instead of 0.5x, you can have x minus vt. You can have x minus vt, or y equals a sine kx minus omega t. So if we compare this, one in bracket with this one in bracket, we can say k, our wave number, is equals to 0.5, and our omega is equals to 50. Then it means that our a is equals to 0.3. So the amplitude of this question is 0.3, and that makes option D the correct answer. All right, let's go to question 5. A plane progressive wave is represented by the equation y equals 2 sine 200 pi t minus 0.5x and all of that. Now, anytime you are given a wave equation, you must always compare it with something that you already know. So there's a wave equation that says a sine. So instead of 200 pi t, I can have 2 pi ft. 2 pi ft minus phi, because phi is 2 pi x over lambda. All right, so you can have, let me just write it out for you. You can have 2 pi x over lambda, something like this. So comparing this with this shows that 2 pi ft is equals to 200 pi t. What are we told to find? We are told to find frequency. So if you make frequency dissolve formula here, you have 200 pi t divided by 2 pi t. Pi t cancel pi t. 200 divided by 2 is 100 hertz. So the frequency of this wave is 100 hertz.